Um, so we have a kind of an outline of how to solve a problem. What do you guys? What's the immediate reaction you have when I say word problems? Anybody have an immediate visceral reaction? Anybody get sweaty? Yes.
I just think of kids getting like Sally's getting 40 watermelons. Like what she's doing is 40 watermelons.
Yeah. That's. Do I have that on my?
Yeah.
I did. I love that one. Yeah. Who? Where else in math but math would you be able to buy that many cantaloupes or whatever? Nobody wonders what the hell's wrong with you. I love that. Or I always think about trains. Train heads north, going. Another train heads south. How long until that kind of problem? You remember these kind of problems? You guys, how are you doing? Are you feeling okay? So those are algebraic word problems. And people don't like them because it is a very difficult skill to translate from a bunch of English into mathish, right? What we're going to do is algebra might be the right way to do something sometimes, but you're wide open to using all these different methods. Okay, I like it. So, kind of the outline to any problem-solving attempt. Oh yeah, you got to move. Let's see. Did I guess not. Shoot. Oh, that's coming up. That's right. First thing is understand the problem. And this is a beautiful example. If I write something on the board, you might want to ask, what did you write, Jeff? Because, I feel bad for you guys trying to understand this. You all thought it stopped at the symbols for numbers in other languages. This is my own personal language. Right, so this is kind of a step that's really easy to miss. You kind of jump, you see numbers and you start doing stuff with them, but did you really stop and think, what does this want from me? What kind of answer should I expect to this, right? Do you understand what it is they told you? So on a test or a quiz or something, you should feel comfortable coming up to my desk and saying, I don't know what you meant here. Can you say this a different way, or, right? And I'll translate it. So first step is, do you really get what the problem is just saying in a real life kind of manner? Do you understand what to expect? Should the answer be a word or a number or something? Yes? Secondly, once you understand the problem, you want to devise a plan. Okay. You want to figure out, do we need grappling hooks? Do we need... What do we need? Do we need flashlights? No. So devising a plan. We're going to talk about several different possible plans to implement. This will be stuff like, I'm sure you guys have heard this, guess and check. Have you heard of guess and check? Anybody ever heard of guess and check? That's where you just have a problem and you just guess when you see if it works. And if it doesn't work, you guess again and you see if it works. And if it doesn't work, you guess again, right? So normally people use that for factoring. Could be one like algebraic way where you use it. Or even where I say 3 consecutive numbers add to be 87. Can't you just guess and check your way to that? Right? Yeah. Okay. So that's one thing. There's going to be several things underneath here. We're going to talk about that in a minute. All right. So remarkably enough, once you've devised a plan, what do you think you're going to do then? Say again?
Revise the plan.
Oh, revise it? Oh, revision would be after this next step. So once you've got a plan, you're going to just go ahead and carry out the plan, right? And then in the middle of it, if you're like, this is getting me nowhere, you might want to go back to step 2 and revise it. I love it. So you might have picked the wrong method to try, right? So third step would be carry out the plan. And so I like what you just said. You might have to go back and revise the plan. I'm going to add that in because that's a good point. If you figure out that the thing you decided to try is not going to work. Right, so you're going to scale the wall and you're all like, I don't have the upper arm strength for that. Okay, so maybe we want to see, is there another way in? So we go back and revise the plan. And then finally, there is a thing the book calls look back, which just sounds weird to me. And what they mean is, did you answer the question fully? Did you give the units for it? Does it make physical sense, right? I still love it when a student told me that a shed I was building should be -4 by -5 feet. And I said, is there nothing wrong with that? And they're like, that's what the math told me. I'm like, how? Do you need black hole material? Do you need, what kind of stuff is this? Should I not go near the shed? Am I gonna get transported to a different dimension in this negative length? Sorry, that's all for me. Look back, make sure the answer makes sense. Make sure you actually fully answer the question, all that kind of stuff. Okay. Nothing ground shaking here. The big thing is gonna be this part. What are we allowed to do? What are we, not allowed to, but what can we try? What methods can we try? And the first one, of course, is the one I already talked about. The book calls it guess and test, which just doesn't sound right to me. I'm going to call it guess and check. So, like, here's something, I don't know if you guys have ever seen this. Let's do a real quick problem together. Can you put the numbers 1 through 9 in a 9-spot grid so that every up and down, left and right, and diagonally, the sum is the same?
Sudoku?
Not quite Sudoku.
No.
But I like that it is kind of sort of in that vein a little bit. Has anybody ever seen this kind of problem before? Does everybody understand what I'm saying? So like, I want you, if you put 1, 2, 7, that adds up to be 10, then every way you look at it should add up to be 10 when you're done. You guys kind of with the problem? Now, does anyone have, I'll let you think about it for a minute. Let me know if you don't understand, because that's the first step is, did I explain what you have to do well enough? And if not, just go, could you try one more time? Okay, so you could try, so let me kind of break down guess and check a little bit. You could try truly random, just truly random guess and check, which would be a little chaotic. Which means make one full square, just kind of put numbers 1, 4, 8, 2, 5, and then watch me answer it. That'd be hilarious. 9, 6, I don't know, what have I left out? 7, 3, and then, oh shit, erase, do it again, right? Does anyone, will that sometimes be good? Yes. Why is it not so good here? To just kind of truly, totally, randomly, without thought, just throw shit in there and erase and do it again and erase and do it again. Why isn't that not a great plan? When do you think that might be okay to do, just randomly throw stuff in there? If I had less possible things, right? There's too many combinations here to just do random guessing. Does that make sense? Yeah. So the more possible combinations and orientations and stuff, the less I want to do just random guess. So let's not random guess. The second thing, always forget the middle dude. Oh yeah, systematic. And this is where you would stop and think, what sort of needs to happen for this to so try to think ahead of time. Is there something that should be in a certain place so that this will work? So let me write out the numbers. I don't know. There is a certain number that should go in a certain spot.
9 in the middle?
9 in the middle. And actually, I don't know if there might be other ways to do this, but to me, what number is in the middle of the list? 5. So what number should go in the middle of the squares? 5. Yeah. So that systematic is kind of like, it's not totally random. You're trying to put a system in place. Let's see what happens if I put a 5 in the middle and then start trying to do things and just do it a little more. Start with some assumption to begin with. Don't just completely randomly do it. Okay, I like it. And then the last thing is inferential. And that is sort of like building off a systematic. As you try to do things, you sort of learn more about what might work and what might not. So that is one thing I randomly did up here, is I did put 5 in the middle, but that won't work. So here's something else I want you to realize. Let me tell you one more thing that will help you with this. Does anybody think they're onto something right now? Anybody? I see some of you guys working on this. And I know some of you guys are like, I'm just show me what the hell to do with this math board. Anybody have any ideas? No? So let me ask you this. What's 1 plus 5 plus 9?
15.
Yeah, 15. What is 2 plus 5 plus 8? Holy shit, of course it is, right? Make 1 go up by 1 and 9 go down by 1, it's still going to add to be the same thing. And now you see why 5 in the middle, everything's going to share 5 if it's in the middle, correct? All right, now try to do it. See, now we got enough of a system, put 5 in the middle, and a little bit of inferential stuff going on, meaning I figured out that the sum that it's supposed to be. Now what you want to figure out is 5 is here, and I know I want 159 to show up. What's the next level of thing you're concerned about? Because if I just kind of blindly do this, 159, 258, what's already screwed up here? That's going to add to too much, correct? Okay. So I've got to be careful how I put these in here. So go ahead and work on it for a little bit. And again, let go of having to get to the answer right away. What's most important is what you're trying to do. So every time you guess something, you learn what's wrong with that guess if it doesn't work. So the more you do, the closer you should get to the right orientation, is what I'm hoping. So let me know if you think you got the answer. Let me ask you real quick. Let me point something out. Just to kind of, and the funny thing is, the more you do solving problems, not necessarily word problems. This is not a word problem. Would you agree with me? This really is not a word problem. But the more you do solving problems, the more you understand what you can do. Does anyone do crossword puzzles? Yes? Anybody else? So, yes? So a friend of mine, her and her mom do crossword puzzles, and they just know all these little in things, like little clues that are always the same thing, and I have no freaking idea. I don't do crossword puzzles a lot. So the more you do anything, the more you'll know kind of what to look for, what to feel out, and some stuff. 5 is in the middle. We know that the sum is 15, correct?
Right.
So therefore, anything that's across from 5, what do these two things have to add to be? 10, right? So that's an immediate thing to realize. Now, obviously, if you just listed out all these, it would already automatically be in there, but those have to add up to be 10. Okay. So, obviously, though, if I put a 2 here and an 8 there, the 8 and 9 suck. So I need a small number with the 9, correct? Yeah, so let's try that. So if I try to put the 8 there and the 2 there, this works. This is 11, so what would have to go here? A 4, right? And this is 12, so what would have to go here? A 3. This is 9, so what would have to go here?
1. Oh,
6, right? Make 15, is everybody with me? And then this is 8, so this has to be 7. And something really kind of cool. And again, we sort of got there a little bit quickly, but do you guys follow the kind of, so as you try, you start to realize the mistake. So you just write something down, you're like, I see the mistake, that's too big. So then we switched it around, we just got a little lucky. And then check this out, this will be 15 also, this is 15, this is 15, this is 15, 15, 15, 15. But notice this, what's true about these numbers here?
Odds.
And then these numbers, even, yeah, isn't neat. Sorry, it's kind of neat. So is that the only possible answer? No. Right? Because I did the 159 like this, that kind of led to this. You could have orientated your 159, well, that's the English version of orientate. Could have done it this way and see where that led. Okay. All right, you guys are almost interested, yes? Sure, and it's on the video too, so either way. Good. So, last semester, some people in my class came in and they said, Mr. Waller, we're going to make you TikTok famous. And I said, no, you're not. Shut that shit down. So yeah. All right, that's guess and check. I'm going to say guess and check. The book is going to call it guess and test. They're wrong, it's all good. Yeah, I got these are the 3 kind of subcategories from most chaotic to least chaotic. Right, this one is just no thought. Throw numbers, look at it. Next level, and let me see. The next level for a plan you can use is drawing a picture. We sort of drew a picture there, of course, but sometimes this will be really obvious that you should use it. For example, if I said, draw a square, draw in the diagonals. All right, draw a square, draw in the diagonals. How many triangles did you just create?
4.
Are you sure? So I agree, there's 1, 2, 3, 4. What about this one? Oh, yeah. You guys have heard that kind of problem before, and aren't they kind of like frustrating? They say 15, it's been like, no, it's 16. Everybody, shut up, right? But again, the answer doesn't matter as much as the work you're doing. So if this was a homework problem, I would desperately need you might want to even bust out the color pencils, right? And say 1, 2, 3, 4, and then have this in red or something, 5, and then 6, and then 7, and then 8, right? Is that all of them? There is a problem, I think, like this in the homework, if I remember correctly. It's just a little worse. So enjoy that one. Did I have a second one? No, I will later.
So that's 8. total, right?
Looks like 8, right? Looks like 8. I'm open to more. So there's 1, 2, 3, 4, 5, 6, 7, 8. Does anyone see any more? I don't see any more. I think that's it. Okay. I like it.
It's evil.
Let me know if you see any more. It is a little bit evil. I'm a math teacher. I did pass my evil class with an A++. The third style is the one you guys kind of think about the most, using a variable. All right, and this is the one that kind of relates to word problems. When I say word problem, you start thinking about buying a shirt at such a percentage off, or getting on a train, or whatever. Right. So let me give you a slightly different problem than you might be used to. Prove that the sum of any 3 odd numbers, Jeff, 3 is spelled with 1 R, buddy. There you go. Any 3 odd numbers is odd. If you want better grammar, I could put the word that in there. Okay, but anyway, you get it. Prove that the sum of any 3 odd numbers is itself odd. What the shit? Can somebody tell me, what is an even number? What's the basic idea of an even number?
Can be cut in half.
Can be cut in half, can be divided by 2. So if I wanted to write the most general even number, an expression that would mean any even number. So what's the first even number? 2. And what's the next even number? 4. How does that relate to just the natural numbers? 1, 2, 3, 4. How do we get from one to the other one? If I start with 1, 2, 3, 4, how do I make them all even?
Multiply by 2.
Multiply each one by 2. Okay. So if I wanted, and I know this says odd, but we're trying to build our way up. We got to start with even because that's the easy one. I could write any even number in one go. Here's every even number that exists. Here it is. Yay. Where n means natural numbers. So 2 times 1 is 2, 2 times 2 is 4, and so forth. So 2n is every, calm down, John, every possible even number, right? How do the odd numbers relate to the even numbers? What's the first even number?
2.
Where's the first odd number?
1.
1. Next even? 4. Next odd? 3. 6. 5. So how does every odd number relate to every even number? There's a relationship between them. You could do it.
Less than the even number?
Yeah, it's 1 off, right? It's off by 1 from another even number. So I could do any odd number. I could do it like this. 2m minus 1. Why don't I say n? Because that already made this number, and I want this to be its own independent number. Now stop and think. Does this make sense? All right. I like it. So this is something called, all right, we're not going to suddenly make this into a proof class, don't worry. But this is something called construction method of proof. I'm going to construct what this needs. What does this need for me to look at? 3 odd numbers. Let me construct them. I've got one of them so far. Can somebody help me? Here's one odd number. Let me add that. What's another odd number?
3.
No.
Oh.
That's too specific. What's another way to write any other odd number? Right? So, what makes this unique is m. Somebody give me a value of m. Anything. 2, 11. So what is this number? 3. right? Twice 2 minus 1 is 3. This can't be the same odd number. It didn't say 3 the same odd number. It said 3 odd numbers. It could be anything it wants to be. So all I have to do is change this. Let me just make it A. I have 2 different odd numbers. They could be the same if A equals N, but they could totally be different. Are you guys? Oh, you guys are loving this. I know you're just eating this up. Don't freak out. This is sort of a higher level than what I would expect you to do on your own, because a lot of you guys haven't seen this kind of shit before, correct? But is this at least in the direction of interesting? You don't have to say it's interesting. I'm not going to push you that far. So yeah, I'm not going to give you that. Just keep going, that boy. Okay. So what's another odd number?
2D.
2D? Sure, why not?
There you go.
And again, you can use whatever. You can use Russian letters, you can use Greek letters, you can use whatever.
Variables.
Variables can be whatever the hell you want them to be. So this says prove that the sum of any 3 odd numbers. Didn't we just write this? There it is. There it is. So what should I do with that?
Give it a value?
No. Let me add them. Let me add them up. So what do I gotta get? 2m plus 2a plus 2d minus 3. Is that cool?
Yeah.
I love you guys. I love you guys so much. You're coming with me. Don't worry. You're coming with me. You don't have to be ahead of me. You're coming with me. What does any even number look like? That. What does any odd number look like? This. So I'm just gonna do this. You can add this to your toolkit when you're talking about odd and even numbers. Watch this beautiful shit. You ready? I'm gonna split this up. Ooh, look what I just did. Ooh. Is everybody cool with what I just did? You're like, well, I don't know why you did it, but sure, you could do that if you want to. But watch this. Isn't this even? Isn't this 2 times a number?
Yeah.
Right? And isn't there a minus 1? So isn't this twice a number minus 1? What kind of number is that? Freaking odd, right? Okay, just calm down. This is exciting for me because this is the first kind of introduction to how to handle infinite. I just added an infinite number of numbers. That's exactly what I just did. Because how many numbers could this be? Infinite freaking number. Yeah. So it's a little neat. I mean, this looks really boring as shit, but when you stop to think about what this represents, you're like, what did you do today? I added an infinite number of numbers. Too bad. All right. Anyway, so I really hope you guys kind of get. Does everybody see every step I took? I'm trying to prove that it's odd, and I know that every odd number looks like this. So if I can make the result look like this, it is odd. It would be 1 off from an even. So this is an even number here. I like that it's mad. That's awesome.
Yeah.
Is that why you did that? I'm with you. You're like, let me subtly tell him how I feel about this.
Yeah.
So this is an even number, minus 1, so the whole thing is odd.
No, I think you're mad. Like.
Oh, totally.
Mad
Yes,
science.
this is good. I try to control my mad. There's a method to my madness.
Exactly.
Sometimes.
It's like, it's mad.
Let me see. Was there something else I want to say about that one? No. That is really freaky. Is everybody with me? Would you ever have thought to do that by yourself? No. Why not? Because you've never been shown you're allowed to do this, right? You've never been shown, I don't know if you've ever been shown this. You kind of inherently know, but you might never have written this. You just know it's divisible by 2. This is how you write a number that's divisible by 2. 2 times n. And odd numbers are 1 off from those.
Yeah.
And then I can do shit with these. It's kind of nice. Okay, I'll stop. So let me show you another one, because that's a little freaky. I think I have another one, right? Queued up. Yes, I do. Oh, this one's really cool. Okay. What I'm doing is, I think I am slowly making you think that when I say this is cool, that the exact opposite. I don't know if you guys, I don't know how you feel about it. I don't think we talked about, I feel like I have talked about this. The sum of the first 100 numbers, have we talked about that yet? No. Maybe it was another class. So there's an urban legend in mathematics They're not going to make a movie out of this. Sorry. There's a man named Gauss. So have you ever heard of Gauss?
Yeah, it was a child prodigy.
Yes.
Yeah.
Anybody, you might not have heard of this. Back in the day, do you remember when TVs, do you ever see TV that had like a lot going on in the back? It's the cathode ray TV's like this wide, right? I know nowadays they're like, eek. But they had a cathode ray tube and it shot little electron beams at the screen. It was actually kind of cool just to think about that. If you brought a magnet next to the screen, it would warp that part of the screen. So I got in trouble for doing that to the TV. My mom's watching her Days of Our Lives. She's like, it's green on there. Anyway, so there's this interesting device that is a circle. It runs a current through this and generates a magnetic field. It's called a degausser. And you would kind of wave that across your TV set and it would degauss that. It's just like a little magnetic field set. Gauss, his name is used as the unit of strength of a magnetic field. And that's sort of like when you know you've made it in math and physics, is when they use your name as a unit of measurement. You're like, all right, that's it for me. I'm good. Sorry, guys. Are you guys still with me? Okay. So the urban legend is, when he was little, the class was unruly. And the teacher said, all right, sit down, add up 1 through 100. Add them up. Now. And he sat down and was like, read the paper and say, okay, I can get a minute of, and Gauss, in about 10 seconds, came up and said, here's the answer, man. I'm going to go throw some shit around. And he's like, oh, man. So the teacher sat down, and the teacher did 1 plus 2 plus 3 plus 4, right? 3 plus 3 is 6 plus 4 is 10 plus 5 is 15. Wouldn't that take you forever? Up to, 97, 98, 99. I kind of did something earlier that might give this away. I did something earlier with the square. It's called the magic square that we did with the 159, all that kind of stuff. I don't know if you guys realize what I did there, but here's what Gauss did. What is 1 plus 100?
101.
101. What is 2 plus 99? 101. Jeff, you can do it, buddy. There you go. What is 38 plus 98? Okay. So if I have a sequence of consecutive numbers, whatever the sum of the first and last one is going to be repeated. How many times will that sum be repeated? 50, because I've got to pair them up, don't I? So it's going to be 100 numbers divided by 2 times the first thing plus the last thing. And this is really cool by itself. I don't know. Hopefully this is a little bit cool. What is that? What does it come out to be? 50 times 101.
50. 5,000.
I mean, come on. No, that's not cool. The sum of the first 100 numbers is 50-50. That's a little bit interesting, yeah? And you're like, sure, man. Whatever. Whatever's going to keep you going there, Jeff. All right. So, does this only work for the first 100 numbers? No. No, it doesn't. So if I had to add, for example, 1 through 500, I could do the exact same thing. What's the repeated sum now? 501. And how many pairs will I make that will have a 501?
250.
Yeah. So it'll be 250 times 501, which is whatever the shit that is. Is it 12,250? Is that enough zeros, John? I don't know. Somebody help me out.
125,000.
What is it?
125,250.
125250. I got close. I was off by 1 0. Okay. Something like that. So that process will work. In fact, it will work even if these aren't going up by 1, if they were going up by 2. You just have to know the number it stops at and how many there are, right? So if I want to do this sum real quick, I could do 18 times 1, 2, 3, 4, 5, 6, 7, 8, 9. This will still work 9 over 2. That's weird, isn't it?
Yeah.
Isn't it? Because, real quick, oh man, I just feel, are you guys still with me? I can feel you like, okay. This is 18, yes? This is 18, yes? This is 18, yes? This is 18, yes? Oh shit. That's half of 18. That's why it's okay. I don't have so many 18s. I have so many 18s and then 1/2 of 18. So what do I get? I get 81. And if you actually add this up, hopefully that's what you get. I don't know. 4, 9, 16, 36, 49, 59, 69, 81. Yay! Okay. Okay, maybe. Has anyone ever seen that kind of thing before? Anybody? No? Okay. All of you. Real quick, just to kind of formalize this. If I say that let's make this specific. Let's kind of ignore this extra piece. This is just a little extra piece. Let's say that I have consecutive numbers starting at 1. Then the formula, no matter where it ends, 1 to whatever, it'll be the last number divided by 2 times the first number plus the last number. All right, so how many numbers you got divided by 2 times the first number plus the last number. So if we want to add up 1 through 50,000, that'll still work. Okay, slightly, almost, sort of, right next to interesting. Yes? Okay.
Very interesting.
Oh, very interesting. I like that. Let's see, where am I? So I always use a variable. Oh yeah, I sort of didn't use a variable, but eventually we did. Okay. The main place where you see use a variable, let me just give you, well, you're all craving some algebra, right? You guys are like, come on, Jeff, show me some algebra. You can do it, buddy. What if I have a rectangle with where, you can do it, buddy, where the length is 3 more than twice the width. Does this start to bring back any memories?
Yeah. Good ones.
3 more than twice the width, right? Make this actually work. Okay. And let's say that do I want to do that? No, I don't want to do that. Let's not do this like a quadratic. Let's not do that. I forgot what it was. Oh, there it is. Okay, let's say the perimeter is 36 feet. What are the side lengths, right? So we can combine, obviously I can combine strategies.
Yeah.
So a really smart idea here is to draw a picture. Try to set this up. Let me see how far you guys can make it. Draw the picture. Let's see if you remember any algebra. And again, no pressure. I'm not going to look at this. Go ahead and make all the kinds of mistakes you can right now. Get it out your system. If only it worked that way. So if you draw it, and here's the thing, let's see. How did you guys utilize, now you could use guess and check, right? Guess and check would work here, is that true? Anybody? Yes.
Yeah.
Because, but you don't know, the answer could be 4.72 feet in one direction and the other, right? That could be the answer. So guess and check for this kind of problem is not the best thing to try, right? So, and obviously I'm talking about using variables. So how did somebody use variables on the next step? Anybody know how to do that? Does anybody remember in algebra, the most important thing is to figure out which piece is just x?
Yeah.
So the length or the width, which one can I just call x or whatever letter you want to use?
Width.
The width. Why do I want to call the width something? Because the length is something with, so I gotta know the width first, right? So in algebra, you call the thing that you need immediately, you should just call it x, and then everything else can build off of that. So if I call the width x, what will the length be? 3 more than twice that.
2x plus 3.
Yeah, 2x plus 3. Oh, shnikes.
Damn.
Now, yes. Now, can you set up an appropriate equation?
2x plus 3 equals. 2x plus 3.
2.
So here's a mistake I see. Don't write this. Don't write this. Can anybody tell me why that's a mistake? You only went halfway.
Right.
So what you really should do is finish your picture out, right? Because otherwise you're going to build this, and my little pot-bellied pig is going to run away. Oh, look at him. He's, oh, little mutant pig. He's going to go, ah. All right, I need him to stay. All right? I'm not going to eat him. He looks cute. So that's halfway. I'm going to come back to this in a minute. But if you want to do this correctly, you got to go x plus 2x plus 3 plus x plus 2x. Now I've gone all the freaking way around. I went all the way around this thing. And that should make 36. And now listen, you might have come into this class thinking you would never see any algebra in here. But at the upper edge of elementary school is where you get into pre-algebra and maybe even algebra, depending on the students' capabilities. Correct? And, you know, I'm going to throw in algebra whenever I can. So, is this part easy? This hopefully is the easy part, yes? I got 3x's and 6x's plus 6 is 36, and 6x is 30, so x is 5. So that's the width, 5 feet. And so this will be 10 plus 3, 13 feet. All right, and real quick, I want to come back to this halfway thing. If I do write this, I have gone halfway. So what does it equal? I've gone halfway. 18. And just real quick, 3x. Oh, Jesus, Jeff. Good job, buddy. 3. Okay. So 3x equals, subtract that 15. X equals, I get the same answer. Of course I do, because it represents, if I go halfway, it should equal 18. I should still get to the same answer, of course. Okay, enough of that, sorry. It's not algebra class. I'm not going to spend a lot of time on it. But hopefully this is a little familiar, yes? And then remember the look back thing. If you just circle this, you're wrong. For 2 reasons. 1, 5 what? And this is where I'm a real dork, and I say 5 shoes, 5 watermelons, right? So 5 feet, and then you didn't answer the complete question. I want to know, well, I didn't really say, but I want to know the full dimensions. So you're going to give me that other side too. Okay. So that's what the last step means. Make sure that it makes physical sense. You gave the units, and you answered the whole question. Okay. Let me see, what time is it? I think we might, yeah, let me see. Let's do, I have a handout that will drive some of you a little crazy, but I think maybe less now that I made it a real big deal that the answer is not as important as the work. Because some of them get a little freaky. But let me do a couple real quick things. I forget which letter I'm on. I must be on D. I can figure it out, Jeff. Oh, I guess I'm on D. Yeah. Look for a pattern. So, math really is all about patterns. It's sort of like when I figured out how to write even numbers and odd numbers. I knew the pattern. Like I said, how the odd numbers relate to even. They're always 1 off. That's the pattern we observed, and we captured that in the expression we wrote. The most immediate problem that would relate to this is just a freaking sequence, right, Jeff? So if I wrote 1, 4, 7, Anyone tell me what the next number is?
10.
What's the yeah, it's 10, because what's the sequence?
3.
Just keep adding 3. I like it. What about this one? So this one was basically adding something, right? Here you're obviously not adding something because they keep growing much quicker. Negative 2 times what is 6? And then 6 times negative 3 is negative 18. Negative 18 times negative 3 is 54, so that checks. It's a valid algorithm for this. So then how do I get the next one? I just multiply by another negative 3 just to keep it going. So what would that be?
162.
162, I like. Oh, let me give you one more. Let me see if anybody's ever seen this. I'm almost certain some of you guys have seen this. I'll give you a few extra. Fibonacci. Which actually, some math teachers put a little too much importance on it. At the same time, it is remarkably important. Right? It's besides you. I know you probably know the pattern. Has anybody else ever seen this before? If you've never seen it before, can you see what the pattern is? It's a little freaky because it starts with 1 and then it goes to 1. You're like, what? But so think of these as one unit. 1, 1, and then somehow they make 2, and then somehow something makes 3, and then somehow something makes 5. What's 1 plus 1?
2.
2. And then what's 1 plus 2?
3.
And then what's 2 plus 3?
5.
3 plus 5?
8.
Blah, 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 blah. Okay. How big are note cards that you get for making notes on, and formula sheets and crib sheets?
3 by 4.
3 by 4? Aren't they 3 by 5? Have you ever gotten a 3 by 5 note card? No? Alright, maybe that's back in my day. I don't know. Alright, but 3 by 5?
For studying stuff, like flashcards.
Yes, exactly. Alright, that's enough about it. I literally could have 3 classes where we do nothing but talk about Fibonacci sequence. If you're curious, go home and type Fibonacci anything, like Fibonacci music, Fibonacci stock market, Fibonacci surfing, Fibonacci whatever the shit. It has implications in a lot of different things. My friend Sean, who passed away recently, he was the financial advisor for quite a few big companies, and he made money during the recession using a Fibonacci algorithmic approach to stock buying and selling. The number of little hills, he would wait until it was in one of the Fibonacci numbers, and then he would buy or sell, and overall it made him money. I'm like, that's freakadelic. I don't have enough money to do that, but that's neat to see it in action. Anyway, so that's the most basic way to look for a pattern. Did I have another one? No, yeah, good job, Jeff. All right. So let's do this. What time we got? No, I think all right, maybe I'll do this next time. Don't worry, don't worry, I love that. Don't worry, guys, don't worry, we're not leaving yet. Don't worry. Sorry. I was just trying to figure out if I want to start this now or start this next time. We have 2 other kind of methods to talk about. And then I might give this out and do like the first problem with you. The next one is make a list. That's it, make a list. So what would that have to do with? The most obvious example of this for me is this kind of problem. 2 numbers, add to, what do you got, Jeff? I don't know. Oh, I forgot to make a problem. Let me make a problem. Okay, there it is. Add to 19 and multiply to 60. What are the numbers? Do you understand how make a list applies here?
Yeah.
So let me just tell you ahead of time, some of the homework might say use this specific strategy. You must use that specific strategy. You can then say it would work this way too, but if they're specific in which strategy they want you to use, you better use that strategy. And that isn't me being an asshole teacher, that is the book trying to get to make sure that you understand each strategy. I'm an asshole teacher for other reasons. So 2 numbers add to 19 multiplied with 60. What kind of list could you create to start looking at what this is? And does everybody understand what this problem is asking us?
Yeah.
For example, don't 9 and 10 add to 19?
Yeah.
Do they make 60? No. So what kind, there's 2 main kinds of lists we could create. Can anybody give me a list you could create to start figuring out this problem out?
One that adds 19.
Yeah, I could make a list of all the numbers that add to 19, or I could make a list of all the numbers that multiply 60. So what we're doing when we're doing that is we're making a list that meets one requirement, and then we're eliminating the ones that don't meet the other requirement. Kind of makes sense. Which list do you want to do? Or go ahead and do the problem. I'm just going to stand here for a while. Go ahead and do the problem either way you want to. Make a list of all the 19s or make a list of all the things that make 60. See if you can get this figured out. As I make sure I did in my head correctly. Yes.
Did you get one of those here on campus?
No. I got it from Albertsons. Okay. Did they sell them? Did they sell these on campus?
No, I don't even know.
I think they do Gold Peak. Yeah.
It's all Coca-Cola.
Huh?
They're all, like all the teams.
Oh, yeah, I know.
Yeah, they're all.
It's funny how that works with so many things.
We did a
I
tour.
like this thing. It's just, well, it's the same color.
We did a tour of Coca-Cola in Atlanta, and it was like, damn, dude, even the baby food.
It's crazy.
Like insane.
It's crazy. So like if you do this, you could do 1 and 18, 2 and 17, and 5 and 15, 5 and 14, and you start checking. All right, so you should see the answer already. The factorization one might be a little freakier, yes? 6 times 10, right? What else you got? 2 times 30, 3 times 20. Because the answer is one of the least remembered ways to do 60. What's a quarter of an hour? How long is that? 15 minutes. So what's 4 times 15? Oh, okay. And of course that, you don't have to make both lists. But once you get to this part of the list, it works for the other thing also, yes? And what is this? Does this sound familiar to anybody in terms of algebra? Did you use this skill in algebra anywhere? And again, do not be freaked out. I'm going to write something. Oh shit. Something that your kindergarten students will be working with extensively. No, don't do that. Don't do that. The question I would ask you is, can you factor this? And it was all about numbers that multiply be the last dude and add to be the middle dude. Does that sound at all familiar to anybody? Once you get 4 and 15, there you go. You factored it. Is that familiar? Is that not familiar to anybody? Well, I don't want to point you out like, I have no idea what you're doing. No, don't worry. I'm not good. So real quick, when I teach this one complete side note, what could X be? What could X be? Anything, yes? Somebody give me a number. 5, okay, thank you. All right. Stay with me, this is so cool. If X is 5, what number is this? 5 squared is 25, somebody help me out. 25. 19 times 5 is 100, is 95? 95. Well, it's just 95, right?
Yeah.
So that makes 180, yes? I think. You guys with me? And again, you could have picked any number, yes? But if x is 5, this number is 180. What's this number if x is 5? 9. What's this number if x is 5?
20.
Isn't 9 times 20 one way to factor 180? So I like to show my students, this is the concrete idea behind the freaky ass conceptual thing of factoring. So when you factor this to this, you have just factored in an infinite number of numbers. Because x could be an infinite number of things. Freaky. All right.
Yeah.
It's kind of cool. Anyway, I'll stop. And real quick, anyway, if you're going to teach something, you should be so interested in it that you have little side notes to give, because that's what kind of rounds it out, at least as far as I think. And I don't care, really. If it did nothing for you, I would still give you freaky little side notes, because they're just neat. All right. Oh, that one's going to be, all right, let me see. Yeah, let's do this. Let's say, I'm not going to tell you the name of this method yet. What is this? Method F, to be determined. Here's the problem. You want to bring this with you. I mean, numbers don't really matter, I don't think. I just made this shit up. All right. You got to go 9,876,412 miles, right, in your spaceship. And you're going 80,000 miles. Let me make this worse. You're going 81,499 miles per hour. How long will it take you? Okay. Some of you guys might see what to do, but if you have any trouble seeing what to do, this strategy is one of my favorites. I use it a lot. And it's called solve a simpler problem. So what I'm going to do is I'm going to change the numbers. Because the math won't change just because I changed the numbers they gave me. Does that make sense? The math won't change. I'm going to still have to do whatever the math is. So what if I had to go 100 miles and I was going 10 miles an hour? Can you tell me how long it would take you to do that?
10 hours?
Right? You would do what with the two numbers? Divide them. Therefore, you would divide these because they represent the same things. So that's the most direct example of solve a simpler problem I can tell you. It's when the numbers get in your way and your brain is like, I can't, what the 9 million, what? So you think, okay, brain, 110. Your brain goes, divide, right? You guys had to think back to what you did. You're like, I divided, because your brain just knew. And you go, okay, brain, we'll do the same thing, but we'll do it in the calculator, brain. Give you a break. I almost don't care what the answer is, right?
Yeah.
What's important is what to do with it, yeah. Okay. So, I'll tell you what. I'm going to give you, I like it. Yeah, I'm going to give you this. We're going to do the first problem, and then we're going to finish this up on Tuesday, right? So maybe if you want to, you can kind of tease these over. If you don't want to look at this at all, just make sure you bring it back next Tuesday. Oh, did you see that last part? Jeff. I'm doing this the most inefficient way. Euler would be upset with me. Yeah, of course. Yeah, we're probably all going to leave a little early, so that'll work out. All right, so I'm going to read this first problem for no specific reason, because I think it might help somebody out there. Consider the following problem. Find 3 consecutive counting numbers whose sum is 78. So we know many, many different strategies now. Obviously, I would love it if somebody tried drawing a picture, but that probably won't help much, right? It says to use 3 different methods. But let's see if you guys try to do one method. So figure out 3 consecutive numbers that add to 78. It's wide open. Whatever method you can use besides Googling it. Quick side note. I had a student Google the homework questions and then copy the answers. And I said, I could tell. I'm like, you did it. And he's like, well, I did the work. I typed the stuff in. I got it from, I did the work. I did the research. I'm like, oh my God. Hopefully you understand how wrong that was, yes?
Yeah.
He was pissed at me, and I'm like, fine. Be pissed at me. Just make sure everybody really understands 10, 11, 12 are consecutive numbers, but they obviously don't add it to be 78. So you could use, what would I do if I just kept doing that? What method would that be?
Guess and check.
Guess and check. It would be above random because at least if I do whatever I just said, I forgot, 12, 13, 14, and I'm like, it's too low, I know to make it higher. So there's a bit of a system to what I'm doing then. So it's systematic guess and check. But what's, I don't know, so that's one method you could use. Is anybody trying a different method? Or is everybody doing guess and check because that's what I said?
Well, I did think of going directly to drawing a picture, how you said,
Oh,
and then.
you took that as a challenge. I was hoping somebody would.
Well, as I was gonna draw the numbers and start, pretty much going like that, I kinda, made the math. I was like, which number should I start by? And then I was like, well, if I go by here, this is too high. I got it.
All right,
So,
all right.
technically, it did help.
In a roundabout way, I got you.
Yeah. And then, guess and check. I think it would apply into that, like, which number should I start writing down?
Yeah, so I mean, guess and check is not horrible because this is 78's not big. You should be able to home in on it kind of relatively quickly. But did somebody do something that wasn't just guess and check?
I used the variable.
Oh, sweet. Who said that? I'm sorry. I'm looking in the wrong place. Obviously, being a math teacher, that just, makes my day. But that's not the only way you can do this. How did you use a variable?
We did x plus 1.
Oh, cool. All right, so this is the freaky thing. So I have the first number, the second number, and the third number. I have 3 numbers, yes? And they are consecutive numbers. We have no idea what any of them are. So like I said earlier, one of them's got to be x, and the other 2 build. So if I make this x, this isn't y, because it's related to the first dude.
Mm-hmm.
Obviously, it's one more than the first dude. Just like you said. And then the third one would be?
X plus 2.
Because it's one more than that dude. Isn't that neat? No? All right. And then I just do what it said. These add up to be 78, and then I solve it. Yeah. So algebra is one tool to use for a problem like this. Sometimes it's the best tool, sometimes it sucks. Oh, you got 3x is 3, subtract 3, divide 25, so you get 20 by 26. Okay. Did somebody else do a different method? Well, let me do this the right. Anybody do a different way? Yes.
I saw a pattern.
Pattern?
Yeah, I did this. So I was doing guess and check, and I saw that, and the next one's like.
Oh, look at you. All right. So you started off with 21 plus 22 plus 23, is that right?
Yeah.
And that was 66.
Yeah.
And then you did 24?
Oh, I did 22 plus 23 plus
Oh,
24.
you went up one step.
And I saw that you just add the answers are just plus 3, so I just did 3 plus 22, and I got 25, so it'd be like,
Okay, sure. I love it. Have a guess, another guess. You saw how they related to each other. That's how you combine these different strategies. I like it. I haven't heard the one that I normally get the most yet, which is interesting. What about this? 78 divided by 3 is what?
26. Oh, that's what I did.
That's what you did. Tell
I
me.
think
Tell me.
Oh. Okay.
I'm sorry. I'm not. You don't have to. You don't have to. But I didn't know if you were sitting there thinking I did this wrong.
I thought so, but.
No.
I did it just because I was like, why not?
It's beautiful.
And then I got 26.
Yeah, so if you divide it by 3, you get 26. So 26, 26, 26. But that's not matching the requirement. So then you make 26, 25. So the other one go up to 27.
Yeah.
Then you got 25, 26, 27. Does that make any sense? If 26 plus 26 plus 26 is 78, then 25 plus 26 plus 27 is also 78, because you lost one and gained one. That's beautiful. Now that's when people try to do that in my algebra class, and then I have to be no, right? Because in algebra, you have to use variables, because that's the whole point. And when I teach algebra, I tell them, if you were taking a driving course, and the final exam was to drive to the mall, and you walk to the mall, and you call it, and you're like, I'm at the mall, I passed. You're like, the car's still here, dude. You didn't use the correct thing in this class. Anyway, I'll stop. We're not in an algebra class. Okay. Yeah, what do you guys think? Is that all right? Should we stop there? Why not? Let's stop there. So we'll pick up with this on Tuesday. We'll have that quiz on Tuesday. That's fantastic. Gonna get some grades going. Always a good thing.
So
Bring this back for sure. I'll have some if you forget it. And we'll finish that up next time. And we are right on track, so everything is good. Let me know if you have any questions or